In this video, we're going to calculate the frequency of radiation of each of the following wavelengths. We have our first, which is at 573 nanometers, our second, which is at 0.164 centimeters, and then our last, which is at 9.28 times 10 to the negative 9 centimeters. For each of these equations, in order to calculate the frequency from these wavelengths, we're going to use the same equation for each of these examples, which is frequency times wavelength is equal to the speed of light. In terms of symbols, this is going to be nu, which is in units of per second or 1/2. Lambda, which is going to be in meters. And then finally our speed of light, c, which is in meters times per second or meters over seconds. If we wanted to rearrange this, since we're trying to calculate the frequency, so that times that is equal to that, we could rearrange it into nu is equal to the speed of light divided by lambda, or our wavelength. Now that we have the equation, we can go ahead and solve for this. From this equation, we do know that c, the speed of light, is going to be treated as 3.00 times 10 to the 8 meters per second. So now let's plug in our different values. So we have I, which is 573 nanometers. Now it's important to note again that our wavelength needs to be in meters in order for this equation to work. And that's because our speed of light is also in meters. So to simplify things, we're going to take all of our numbers here, 1, 2, and 3, convert those into meters, and then plug them into our formula. If you plug them in without converting them, you will get the answer wrong. So to convert nanometers into meters, we're going to multiply it by the following fraction. For every 1 meter, it's going to be 1 times 10 to the 9 nanometers. So as we solve this, it's going to be 5.73 times 10 to the minus 7 meters, which is equal to 573 nanometers. Now that we have that, we can now replace it into our equation. So nu, is going to be equal to our speed of light, which is 3.00 times 10 to the 8 meters times per second, divided by our new number, 5.73 times 10 to the minus 7 meters. Now it's important, again, as I mentioned before, with these meters, how everything is in meters. We need that because these meters will now cancel each other out, leaving us just with the units of our per second, which is exactly what we need for frequency. So when we do the algebra for this one, it's going to come out to 5.24 times 10 to the 14 per seconds. Now let's do number 2. In this case, it is 0.164 centimeters. Again, we need to convert this into meters. This time we'll use 1 meter over 100 centimeters. Again, doing the algebra. When we do this, centimeters, since they're here and here, will cancel each other out, leaving us only with meters, which is exactly what we want. This comes out to 1.64 times 10 to the minus 3 meters. Again, we can plug this into our formula. Nu is equal to our speed of light, 3.00 times 10 to the 8 meters times per second, divided by our new number, 1.64 times 10 to the minus 3 meters. And just like before, our units of meters will cancel out, leaving us only with per second, which is exactly what we need. This is going to be equal to 1.83 times 10 to the 11th per second. Now on to our final one. In this case, we have 9.28 times 10 to the minus 9 centimeters. All right, since this is in centimeters again, we're going to use the same fraction that we used in number 2. So we're going to multiply this by, for every 1 meter, we have 100 centimeters. And now this is going to be equal to 9.28 times 10 to the minus 11 meters. Now we can take that and plug it into our equation. So nu is going to be equal to the speed of light, 3.00 times 10 to the 8 meters times per second, divided by our new number, 9.28 times 10 to the minus 11 meters. Again, our units of meters will cancel because they are on top and the bottom of our fraction. And this will be equal to 3.23 times 10 to the 18 per seconds. So whenever you're trying to convert from wavelengths into frequency, we'll use our equation, which is equal to nu is equal to the speed of light divided by our wavelength.